Should African Americans be treated with beta blockers to prevent heart failure? Welcome to the Clinicians Roundtable. I'm your host, Dr. Larry Kaskel. Joining me today is Dr. Gerald Dorn, Professor of Medicine, Associate Chairman for Translational Research, and Director at the Center for Pharmacogenomics at Washington University School of Medicine. Dr. Dorn has researched, lectured, and published extensively. Dr. Dorn, welcome to the show.
Thanks, Larry. I'm delighted to be here.
Well, you've got some new research out that was recently published that kind of shakes things up a little bit.
Well, I hope so.
Can we start with just the basics of how does a beta blocker actually prevent or help to prevent heart failure?
Sure. So when your heart fails, when you have a weak heart, the body compensates by secreting a number of neurohormones. Foremost among these, of course, is adrenaline or epinephrine and norepinephrine. And the consequence of this acutely is that you increase your cardiac output just as you would under any condition where you're kind of got your adrenals overactive, like when you're scared, the fight or flight response. So that would be a good thing if it was just a short-term event. But in heart failure, this neurohormonal excess is chronic. And as a consequence of that, it's like flogging kind of a dead horse. There are a number of adverse consequences, including the fact that actually more heart cells die through programmed cell death. And this starts kind of a vicious cycle of neurohormonal activation that ultimately results in cardiac decompensation.
So you're really trying to downregulate all these hormones.
And so beta blockers in particular interfere with the effects of epinephrine and norepinephrine at the beta receptor. And this is very similar to the way angiotensin-converting enzyme inhibitors interrupt the same pathological neurohormonal cascade involving angiotensin. So ACE inhibitors and beta blockers are the only really effective pharmacotherapies in heart failure.
All right, so what made you even think of studying African American patients and beta blockers?
One of the kind of outliers, a serious inconsistency in the clinical data, the clinical trials for beta blockers, has been the apparent disparate efficacy of beta blockade in heart failures between Caucasians and African Americans. And this is kind of well recognized and poorly explained. But in many of the large clinical trials, and this includes trials with bucindolol, which is called the BEST study, Copernicus, and Merit heart failure, each different beta blockers, the efficacy in Caucasian Americans has been quite good. And so there's been like a 31% overall reduction in mortality. The same studies in the same drugs within the African American subpopulation, the benefit has been only 3%, which is essentially no benefit. And so the question is, what is it about African American race that causes this apparent lack of efficacy? And the NIH funded us to do these studies based on that question.
So what was your initial idea, just even formulating the study? How did you even know what genes to look at?
The initial approach, which was undertaken largely by my colleague Steve Liggett a number of years ago, was to look at the direct target of beta blockers, and that is the beta adrenergic receptors. So there's a lot of genetic variation in beta receptors. And indeed, if you look at the effects of having beta receptor variants or polymorphisms, they can alter your risk of developing heart failure, and this can be an event that is unique to African Americans. And Steve and some of my other colleagues from Cincinnati published this in the New England Journal a few years ago. Those genetic findings, however, did not explain any difference in response to beta blockade. That's a different issue and a different question. And so we worked our way down the signaling pathway. If it wasn't the beta receptors, maybe it was those enzymes that modify the response of beta receptors, and those enzymes are called GRKs or G protein receptor kinases.
All right, so tell me about your specific study.
So we did deep resequencing to look for polymorphisms, that is genetic variations in GRKs that are expressed in the heart. And we were specifically looking for genetic variations that alter the function of the kinase of the GRK and that were disproportionately overrepresented in African Americans.
And what did you find?
We found one, and determining what the biochemistry was in cell-based and transgenic mouse systems, we went ahead and did a couple of studies in heart failure cohorts. One was the case control study, which simply showed us that, yes, there is an association between having the minor variant called the L41 variant, and your response to beta blockade. And then we took a cohort, 400 African Americans, and followed them for up to 5 years to see whether or not we could prospectively evaluate the interaction between the gene and the drug. And if you have the gene, the L41 variant, it's essentially like having natural beta blockade. You have the same favorable outcome in heart failure as if you were taking the beta blocker, even if you're not.
If you've just joined us, you're listening to the Clinicians Roundtable on ReachMD. I'm your host, Dr. Larry Kaskel, and I'm talking with Dr. Gerald Dorn, Director of the Center for Pharmacogenomics at Washington University School of Medicine. And we're talking about a recent study in African Americans looking at the presence of GRKs. So were you surprised, or did you really expect to find what you found?
So I was not surprised. I was incredibly pleased. But I would say that many other people were surprised because this particular gene polymorphism has the same biological effects as a drug. It's a pharmacomimetic, if you will, and that has never previously been described. To my knowledge, there are gene variants that will affect the bioavailability of a drug, for example, the efficacy of Coumadin in anticoagulation. There are gene variants that will affect how you respond to a drug. For example, whether you're estrogen receptor positive in breast cancer will determine whether or not you respond well to estrogen receptor blockers. But there has not yet been, or not previously been, an example of a gene that mimics the effect of a drug in a disease.
Well, then, are we doing a disservice by adding a beta blocker to somebody who already has endogenous beta blockade going on?
So our results suggest that there is no adverse consequence to being beta blocked and to having the gene variant. It's either or. And so you might say, well, is it a waste? And I would caution just a little bit because our outcomes were transplant or death. And there are other potential benefits of heart failure, of beta blockers in heart failure. For example, you may feel better. Your quality of life may be improved. Your hospitalizations may be decreased. And to look at those endpoints will require larger numbers of patients than we had in our initial study, and we are doing that. But I think it's premature right now to say that there might not be other beneficial effects of beta blockade that the gene does not mimic.
What needs to take place next for this to really be translated into everyday clinical medicine?
Sure. There are a couple of things, and we're actually well under our way to accomplishing them. One is we need to look at whether or not this effect stands up in a much larger population, several thousand individuals. Second, although the gene variant is disproportionately represented in African Americans, 4% of European ancestry individuals also carry the gene, and we need to see whether or not the biology is the same, and I expect that it will be. And then the other thing that we need to do is we have looked at this strictly in heart failure. Beta blockers are, of course, used in a number of cardiac diseases, high blood pressure, angina, myocardial infarction, and we need to look in to see whether the same type of similarities between gene and drug hold in those diseases. Each of these studies is underway.
If you can predict the future, what do you expect to be the outcome?
I may be somewhat more informed than a crystal ball in this, and things are looking very good. I think one of the implications of this research is the need to perform genetic profiling for clinical trials of novel therapeutics in order to better identify patients who will benefit from them. If the entire population of the clinical trials of beta blockers in heart failure had the same prevalence of this gene variant as did African Americans, we would not use beta blockers in heart failure because the genetic data confounded the clinical data. And so I think companies are going to need to take that into account in an era of genome-based personalized medicine that I anticipate is coming.
Well, you just predicted my next question because it does seem like your study really does support personalized medicine. What companies currently do you think will benefit or are actually ahead of the curve in terms of personalized medicine?
I think there's a great deal of interest in personalized medicine from both big pharma and from small companies. And without naming names, I would say that companies who are looking at drugs that have those targets which are highly polymorphic. So roughly half of all drugs that we use in medicine affect a G protein-coupled receptor or a downstream signaling event. And these receptors are highly polymorphic, so beta blockers, ACE inhibitors, other receptor antagonists. Anybody who deals with a drug that affects those pathways, since there is so much genetic variation, we probably need to be exploring what impact the variation has on drug response. Same thing for any drug that is metabolized by the cytochrome P450 pathway in the liver, because there's so much variation in those enzymes. So this is a very fruitful field.
How far away are we from actually seeing the fruits blossom?
I think we're pretty close. There are already, in the case of, for example, Coumadin anticoagulation, there are already clinical pathways based on genotype determination to suggest, for example, after hip replacement, how much Coumadin you should need. The notion of genotyping cancers to best pick your chemotherapy for that. And I think those types of applications are already a little bit in use. They are growing rapidly. Cardiovascular is a little behind cancer. We always are. But it's just a few years, I think, before we're doing this routinely in the clinic.
Dr. Dorn, how does your study kind of compare to all the studies we read about in the newspapers that are really whole genome-associated studies, where they're really looking at the entire genome, whereas yours is kind of more mechanistically inclined?
Our studies were hypothesis-based. We started with the notion that African Americans seem to not respond to beta blockers. We looked at beta-adrenergic receptors as targets. We then looked at the GRKs that modify the beta-adrenergic receptors, anticipating that mechanistically the genes and the drugs must have a relationship. And we found something. The other studies to which you refer, whole genome association studies, are not mechanistically based. They're called unbiased. So they look at 1 million or 500,000 variant loci across the gene to try to find a zip code, a region of the genome, if you will, that has a relationship to a disease. I think an advantage of the unbiased studies is that they're very, very powerful, and that you can believe them if you have sufficient numbers of patients in your study. A disadvantage is you fail to identify with this type of analysis the specific gene, the specific abnormality of the gene, and therefore you don't really get any additional mechanistic insight.
Well, Dr. Gerald Dorn of Washington University School of Medicine, thank you so much for talking with me today.
My pleasure.
I'm Dr. Larry Kaskel, and you've been listening to the Clinicians Roundtable on ReachMD XM157. To comment or listen to any of our library of podcasts, please visit our website at reachmd.com. And if you register with the promo code RADIO, we will give you 6 months free of streaming ReachMD you can listen to day or night, at home or at work. Thank you for listening.